The contrep environment not only enables the user to automatically report in the Eclipse error log the violation or fulfillment of a performance requirement. It can also exploit the ability that Eclipse error log has to report events with different associated severity levels to handle the performance requirement violations in a different manner, and therefore to make more efficient the process of validating requirements across the interactive exploration of the model. For that, what is done by the framework is we can have a check to the configuration tab of the execution simulation, and we see here that we can associate, or we associate in contrep a given threshold to each severity level, to each error log severity level, in a way that we can map a given criticality level to a severity level. By this means, depending on the criticality associated to the performance requirement, evaluation on it will provoke either an error, a warning, or an information message, or even no type of event log. By this way, a user can configure and can filter and show the errors in a more convenient, or the violations in a more convenient manner to conduct or to drive its interactive exploration. Here we show the default association of criticality levels in a way that we require that the evaluation of requirement has associated criticality 3 or more to report an error event, and then if the violation has associated a criticality level 2, then a warning will be reported, and then still those violations, those requirement violations which have associated a criticality level 1 will be reported. This is what this means. Of course, each methodology can associate the meaning the methodology wants. For instance, one could be associate this criticality 3 or more to errors that, or violations that cannot be admitted in any solution. Criticality 2 could mean, in this case, a violation that maybe could be admitted in not other convenient solution is found, but it's something to consider. While this level could mean, okay, there are some violations there, but maybe they can be admitted, or they are not so important as the others. So now what we can do is just in our exploration, in the conventional procedure, we will change, for instance, some of the values of these parameters, and then study will go on with these requirements. In this case, to save the simulation in this demo, what we can directly do is to assume that another solution will provoke, for instance, some other values. Let's assume that, for instance, the consumption of processing core is raised by a different solution, and that solution is not very good also, for instance, in the sense that it involves some additional time on the response of the flight algorithm tasks, or that, for instance, the mission critical task has also increased in its response time a lot, in this case the average time, or that the monitoring task has also importantly increased its response. And then if we obtain this output from a solution, what will happen after simulation? Well, we have seen here in the configuration that automatically the checking of these performance requirements is done right after the simulation. But in this case, that since we are not involved in any new simulation, we have directly edited this output file. We can simply trigger the requirements check again. And then what we can see here is, here it starts the report, is that we have started the requirements again, and then we see that now the report is showing that there are up to 4 violations. So for instance, we can see here that the power constraint, as a result of the addition of these 4 power figures, is violating the 15 watts limit that was required when stating the requirement. But we also can see that the deadline for the flight algorithm task has been violated. So as well as checking that this value, this value a bit bigger than 10 milliseconds is bigger than the 2 milliseconds that was required in the requirement, it has also a criticality level sufficiently high to provoke an error error event in the error log. There are other violations. For instance, we have the same type of requirement violated in the sense that it refers to a deadline constraint. But in this case, this deadline is not that important, or is not as important as the violation of the flight algorithm. Deadline refers to a mission critical functionality, and so it was violated because, as we can see here, this response time was 500, and here we have in the requirements file a requirement much more strict, 33 milliseconds. So the violation is reported as a warning due to the criticality level 2, and in addition there are other violations reported as an information because they like the violation of the deadline on the monitoring task, as this is not that important, and this task was associated to criticality level 1 here. We can recall here that this file was statically and directly derived from the model, specifically considering the criticalities associated to the deadlines, and if we have a check to the performance requirements, we had also criticality 3 associated to this power consumption constraint.